Question 5, Part D. A ball is dropped from a height of 2 meters onto a hard floor and bounces. After each bounce, the maximum height reached by the ball is 75% of the previous maximum height. Thus, after it first hits the floor, it reaches a height of 1.5 meters before falling again, and after the second bounce, it reaches a height of 1.125 meters before falling again. Part 1. What is the maximum height reached after the third bounce? We can model this situation using a recurrence relation. So that's applying the same operation to a previous result to get the current result. So let Hn equal the maximum height of the ball reached after the nth bounce. So before the ball bounces, initially h0 is equal to 2 meters above the ground. So h1, which is the maximum height of the ball reached after the first bounce, is equal to h0 times 0.75 or 75%. Now h0 is equal to 2, so h1 is equal to 2 times 0.75, which equals 1.5. So to get h2, we repeat the same operation. We take the previous result, so h1, which is 1.5, and we multiply that by 75% or 0.75. So 1.5 times 0.75 is equal to 1.125. And to get h3, we take h2, we multiply that by 75% or 0.75 again. So 1.125 times 0.75 is equal to 0.84375. So interpreting that result, the maximum height reached after the third bounce is 0.84375 meters or 84.375 centimeters. Part 2. What kind of sequence is formed by the successive maximum heights? The sequence is h0, h1, h2, h3, and so on. Now from part 1, h0 is 2, h1 is 1.5, h2 is 1.125, h3 is 0.84375. To get the next term, we multiply the previous term by 75% or 0.75. So this is a geometric sequence with the first term a equal to 2 and a common ratio r equal to 0.75. Part 3. What is the total distance travelled by the ball from the time it was first dropped until it eventually comes to rest on the floor? From parts 1 and 2, we can model the total distance travelled by the ball using this particular series. Now the ball starts off at a maximum height of 2 meters above the ground. It then falls 2 meters to the ground due to gravity, and it bounces back up to a maximum height of 1.5 meters. And that's why I've used a down arrow here and an up arrow here so we can visualize what is going on. Now the ball then drops 1.5 meters, hits the ground, and then bounces back up to a new maximum height of 1.125 meters. It then falls 1.125 meters, hits the ground, and then bounces back up to a new maximum height of 0.84375 meters, and the pattern continues. Now, ignoring the first term, what you'll notice is that the sequence that we had in part 2, I'll just go back to that. Ignoring the 2, each subsequent term is doubled because the ball has to rise up to a maximum height and then fall back to the ground that same distance that's equal to the maximum height. So we can rewrite this series in this way. So taking out the first term of 2, noting that every subsequent term is doubled, we can write it as 2 plus 2 times, open bracket, 1.5 plus 1.125 plus 0.84375, and so on, close bracket. Now what we have in the brackets here is a geometric series, first term 1.5, and a common ratio that's less than 1 and greater than -1, or the absolute value of the common ratio is less than 1. So we can evaluate what's in the brackets here using the limiting sum of a geometric series formula, a over 1 minus r. So we have 2 plus 2 times the limiting sum of this geometric series. So that's 1.5 over 1 minus 0.75. So 2 plus 2 times 1.5 over 1 minus 0.75 evaluates to 14. Therefore, the total distance travelled by the ball is 14 metres.